All right, so here we are in Unit 2 now. We're going to start by talking a little bit about um, different terms in science. The first thing is the scientific method. The scientific method is a logical approach to solving problems. So you observe something, you decide, oh, that's kind of interesting, I want to learn a little bit more about that. You formulate a hypothesis, which is usually some sort of if-then type of statement, just basically making a guess. Now, we do this every day, but you don't usually notice that you're doing it. You make predictions in your mind, but sometimes it feels weird to write it down. We're all pretty good at making hypotheses. But then you test that. So you think you know what's going to happen. Well, let's test it, figure out what happens. Get that data, and then you might be able to formulate a theory based on the data that you collected. So there are qualitative and quantitative observations. So you can observe using your senses, and then sometimes you'll get qualitative data, which is non-numeric. So you don't have any numbers involved. You're looking at descriptions about color, what something feels like, sounds like, so on and so forth. Quantitative has numbers. So for instance, if you record a temperature, you're going to get a number from that. So that's the difference between qualitative and quantitative. A hypothesis, we already talked about this. It's just a guess, okay? So in testing a hypothesis, you have to actually get data that is relevant to what you're trying to support or refute. Controls are things that remain constant. We want to try to control as much as we can so that there's a real small focus on what could be causing the problem. So like if there's a lot of variables going on, you might not be able to figure out what is causing what it is you're seeing. But if you can control everything except one variable, if that variable causes a change, you'll know it. So that's a control, and obviously variables are the things that can change. A model is not just a physical object, it's often an explanation. So, we have like model airplanes, that sort of thing, but then there's like the atomic model or something, the model of the atom. That's not necessarily something you can hold, it's more of a concept. It could be mathematical, or it could be visual or physical. Theory is a generalization that explains a certain body of facts. So it doesn't necessarily mean that's how it is, but it is an idea that takes the facts and gives the best explanation, or an explanation, sometimes it's not even the best one, based upon that body of knowledge that you have discovered. All right, so let's kind of shift gears for a second and start talking about measurements. Scientific notation is something you should know about if you don't already. Basically, you take a number and you're going to raise it to a power of 10 or multiply by 10 raised to something, okay? And this is based on significant figures a lot of times. So when something's written in scientific notation, the numbers that will appear are the ones that are significant, so you can get rid of something. So for instance, in this number up here, you got 2 times 10 to the 11th. Well, in reality, this isn't the best example because there's a decimal point there, which means all of those zeros are significant. Well, you should still have all those zeros. It should be 2.00000 all the way out. So it's not just to make things short. That's what you're taught up till this point. Typically, scientific notation is about making big numbers smaller and more easy to handle, but it's a lot about significant figures as well. So, for instance, all you have to do for scientific notation is start where the decimal point normally is, and then count your places over to the left. So you have 6,378,000. Well, there's 1, 2, 3, 4, 5, 6 places over until you get a number between 1 and 10. The final product with scientific notation needs to be a number between 1 and 10, and then you multiply by 10 raised to the number that you moved over. And then on this one down here, you have a number that is less than 1. So you'll count the opposite direction. 1, 2, 3, 4, 5, 6, 7, 9, 10 until you get a number between 1 and 10. Then, since you went to the right instead of the left, you're going to raise 10 to that negative power. So it's 10 raised to the negative 10th because you went to the right instead of the left. We'll do some practice on this in class, and I think you'll find it pretty easy if you don't already have it mastered. All right. I'm going to just breeze over this. Now, scientific notation in the calculator. This is something that every year people mess up. And what you have to do is use the E button, the capital E button. Some calculators have capital EE, some just have capital E, not the lowercase e. The lowercase e is something entirely different. So if you're trying to type in 4.5 times 10 to the 7th, don't type in 4.5 times 10 raised to the 7th, because once you start having multiple numbers, order of operations is going to get in your way. It's going to mess everything up. So what you want to do is type in 4.5, then hit the EE button. Sometimes that involves, I think on the typical graphing calculator, you do second and then comma. I don't have one near me, or else I double check that. But then you'll type in 7 after that. So it would be 4.5 EE7. A lot of times on the calculators, only one E shows up, and it's a capital E, so it would be 4.5 E7 when you type that into your calculator. And then that just acts as one number. You don't have to do any times 10 anything. So that just acts like the number. So if you were to do this problem down here in the corner on your calculator, you would type in 6.3 E negative 2, then divided by, and just hit the divided by sign, 2.1 E4, and you're good to go. You don't have to worry about order of operations or whatever. If you actually type in times 10 raised to the 7th, you have to use a whole bunch of parentheses and all that sort of stuff, and it gets messy. So I just want to put this in here so that you know for sure and it doesn't get too confusing. All right, that's it for this video. Sorry for the pauses. It's been a little bit crazy around here.